we're going to do GLSL Visuals number 2. The first video for GLSL Visuals was video number 113, so we kind of had some stuff in between this. This is video number 48 of the PAINT5D sprint, which I would say that 48 videos is not much of a sprint anymore, is it? Sprints are supposed to be a little bit, a lot shorter than this, but I'm always biting off more than I can chew, and I never estimate how long things are going to take, right? So hopefully one of my estimates is correct, that I'll get this done before I die. So let's hope at least one estimate is correct here. Okay, so we need to start adding some code in here, and I think the first thing we need to do is just look at the shader code. So the source code for the shader, right? So if P5D10GL, we have the fragment shader here. We're going to open this up, and we're going to start writing some code in here to get some more visual feedback. So we got a whole bunch of stuff going on here. And right now the fragment color is really just based on the frag chord, and we would like to change that around a little bit. Also, we have eye resolution here. Eye resolution here is being used to flip the screen, right? Because the origin we want to use for our graphics is in the top left, but OpenGL likes the bottom left. So we want to use top left. OpenGL coordinate system uses the bottom left, or well, yeah, in terms of frag chords, it uses the bottom left. So that's so the frag chords match up with your traditional kind of math class access, where 0, 0 is in the bottom left. But we don't want to do it that way. So I guess the first thing I want to do is, this eye resolution thing is kind of hacky, I believe. I would like to have some type of eye resolution polyfill, I think. Yeah, because right now, if this is OpenGL code, or sorry, if it's not OpenGL code, then we're hard-coding eye resolution, which we really shouldn't do. We should have some type of polyfill where we can get eye resolution, and then we should be able to use that polyfill function both in the GLSL code and in the C99 code, and it should just be kind of seamless. So let's so I think we could just call it like we could just call it get res, right? Get res, and then we get resolution.y, right? We could call it that. Now, obviously, if we make a function like this, we could be adding, some performance costs, right? Because we're wrapping something that does not need to be a function call into a function call just to get consistency between the GLSL and the C99 code. Oh, also, before I get ahead of myself here, I just want to do something for the record. So for the record, oh wait, I just did my 10 extra. Hold on. So for the record, I did 110 push-ups today. It was supposed to be 110 per day. So now I should try to do more, but the idea is that 110 was the goal for every day. So as long as I get at least 110, I'm not going to beat myself up about it, right? So sometimes I feel more motivated or less motivated on a daily basis. For Friday, it's like 11:26 right now. I barely made it, but I got all I needed done within the current 24-hour period. So Saturday is the last day. I have to do 110 push-ups, and then I get a break day where I don't work at all. So anyways, I just wanted to make a note of that. So let's go in here and let's actually create like that polyfill. I think we should create this eye resolution polyfill. And yeah, let's just do that. So let's go in here. And we're going to do this stream for like an hour because I have to check on some food anyways, and I don't feel like working anyways. So let's do poly OGL. So this is our OpenGL polyfills. And we want a polyfill function, so in here, and we have like texel fetch and these make things, and we also want a GLSL polyfill for GLSL polyfill when we want a get eye resolution, right? We want to get the eye resolution, and because we're using this kind of polyfill and it's a wrapper function, right, we only want to concern ourselves with the X and Y. So let's not have like a XYZW. Let's just have an XY for eye resolution. So we're going to do a float vec2. And the reason this needs to be a float vec2 is because the resolution variables are floats, right? So this resolution Y is a float. So that's just the way we're going to have to do it here, right? Now, do we want to... I don't know how we want to do this. We could make like a resolution Y function as well. I don't know. Float vec2. Now, is this a polyfill, or is this... Actually, this might not be a polyfill. This could actually be a function we have to put in the main code and needs to be, like, wrapped. Yeah, this is actually not a polyfill. Actually, not a polyfill, but a generic wrapper function. Well, actually, hold on. There is no such thing as an eye resolution getter function in GLSL, but we want to create one. The problem is the polyfill is supposed to exist only if it doesn't exist in the GLSL code. So this is kind of like a, it's not quite a polyfill, but it's not quite a function that needs to be implemented. It's actually like, it actually needs to be implemented here, I think. So we need something where it's like a float vec2, or let's do float 32, just to keep this simple. And we're going to call it P5D 1 OGL. And then how about RY but get, like RY get, resolution Y get. And then sure, RY get or get RY. So how about get resolution, and it's a float x, right? It's a float variable, and that is going to take void. And I don't remember how, if we need to do this differently, because if it's interpreted as GLSL, but let's just get something kind of working here. And all I want to do is this eye resolution, we just want to return it, right? So, well, actually, it depends on what kind of code we have, right? So, if def AAC 2020 macro, this is OpenGL. I don't know why I did it if not def, and then because the else kind of was a later thought. So if this is OpenGL code, then we want to turn eye resolution dot y. And else if it's C99 code, we want to return something else, and it is in our, if we look at our CPU uniforms data, it's probably in here. So let's look at CPU uniforms data really quick. And we see we have, like, eye resolution, width, eye resolution, height, right? So we have this variable for that. Now, so let's take that, and let's put that in here. So eye resolution width, right? So, so actually, so I guess res, even for resolution, is kind of like, well, there's no Z in resolution, so why are we doing that? So maybe I should call it res width, right? So resolution width. And that's going to be kind of make a little bit more sense. And we can then take this and we can paste it, float 32. So we have width and then we have height, right? So we have a height, and so this is going to be resolution X. And then this width turns to, oh man, we just messed up everything, didn't we? Okay, so this resolution is Y, right? Because Y is for the vertical axis, it's height, and this is X, right? So there we go. X, width, width, right? So width is here. So width and X go together, and then height and Y go together, right? So simple, right? Now, the next part is, I thought it was going to be in here. But right, so we're going to make a note here of what the heck is going on. And make a timestamp here. So at vid IID. Right, this is video 116, and the time is 12 minutes and 32 seconds. And so if we want to know, like, okay, we were going to do, like, a polyfill, and then we just didn't do it, and why is that the case, right? And the case is because we realize it's not quite a polyfill. Now, the reason why we're going to make a note of it here is just so that we do not accidentally try to recreate it, right? And we could also do this. We could do a float vec 2, right? Float vec 2, and we could say AAC 2020 poly OGL, and then get eye resolution, right? We could actually create something like this and just make a air, right? Say air, and do not make this function. So something like this. DNMF for don't make DNMF, right? So DNMF, don't make this function, right? So we want to make a note. We want to make a note of what we don't do as well as what we do, right? So let's take this and say eye resolution X, same deal. We don't want to make this function either. And we also don't want to make this function. So this is going to be a float 32. This is going to be a float 32 here as well. And we don't want to make these functions. So eye resolution X, eye resolution Y. It also we want to make some control F help, so CTRL F at ctrlf help and get res x get so if we try to search for such a thing, we want to make sure that we don't use these, but we want to put it in here for the record. And then also we want to make a note of what to use. What are we actually going to use then, right? So if we're here and it's like, don't use this function, well, what is the recommended course of action? And the recommended course of action is going to be these functions here. So we're going to make a note of what not to do and a note of what we should actually be doing. So we want res width here, or actually one is res width, one is res height, right? So height. So this is going to be res y, this is res height. And the next part is right here. If they use get iResolution, we want to say get res width and get res height, right? So we're not going to make one that gets both, because a lot of times you only need to get one, and we don't want to waste bandwidth passing around more bytes than we need to pass around. So yeah, we're just going to make this section as a big kind of like do not do this kind of a section, which is kind of awkward, but it's kind of important that we know that there's when we were trying to look for this function or figure out where to put this function, this is initially where we thought to put the function. So it does make sense that when somebody is new to the code base, that they might immediately look in here for such a function. And so, or they might think to put such a function in here. So we want to dissuade, we want to do two things. We want to dissuade from accidentally someone making this function in the future. And then we also want to help people who have gone to this file in search for a get iResolution function and can't find it. Right? So we want to do two things. We want to facilitate ease of going through the code base, and we also want to help prevent the code base from getting messed up in the future. Okay, so now that we have this, there is another thing we have to do, which is well, actually, since it is it returns a float vec2, so even though we do an error, we still have to return like a float vec2. We can do a float vec2 cast fv2, sorry, float vec2 cast with C99 style, and just use 0 minus 666. And these are completely dummy variables, or dummy outputs, or trap values, right? We don't expect them to actually ever be used because we're throwing this error here. Now, it looks like we need a macro for float vec2 and we need a macro for error, right? So if we see here, we have some poly-OGL things here for the data type. So let's go in poly-OGL and see if we have a float vec2 yet, or if we need to create that as well. So we're going to go in poly-OGL data. Once we open that up, we're going to put the data on the left screen, just because data should go on the left and functions should go on the right. Because of the dependency between data and functions. Data comes first, functions come next. And we're just going to look in here and see. So we got float vec4, we got uvec4, we got ivec2, but we don't see anything that is a float vec 2, right? So we're going to just steal this thing, float vec4. We're going to steal float vec4, and we're just going to be float vec2, right? And then we're just going to remove this, and then we can just say, you know, iResolution dot x or iMouse dot x, right? So suggested usages, right? So this is not necessarily what it has to be. But I can definitely see it storing such a value. Okay, so the next thing is, let's just make a note of the video ID at which we added this, because I just like keeping a nice record of what I did when, even though it does kind of like make this file a little bit bigger, so maybe it's a bad idea. But the thing is, even if this is a bad idea in retrospect, well, we can just nuke the comments. But we can't do the reverse. We can't not comment this stuff and then in retrospect say, in retrospect, I wish I had commented it, right? So If in retrospect we decide, oh, I hate all this commentary, well, we can just nuke it, but we can't do the other thing, right? It's kind of like in woodshop, how you can take wood away, but you can't add it. So we can take comments away, but we can't like add them later, right? Because we will not have remembered what video we did this when we come back to this. Like even in a day, we're not going to remember. So good luck in a month when we decide that it's not what we want to do. So yeah, let's just make like a little commentary here about like what's going on, right? So added for we added it for a few things. 1, 2, 3, 4. I believe it's for 5 different things we need this for, right? So we have it for these things here. Do not use. Do not use. And then we also have this thing here. So all these things, and then in the main fragment shader, these are the things that we actually want to use. So, actually no, this is just a float 32. So actually we only have 3 things that it's used for. Use. You can make a note of what to actually use. So what you actually want to use is here. And so basically we added all this extra code just to say, don't do this, right? Which is kind of weird. Now, we're kind of running out of room here. So instead of calling this do not use, we're going to call it don't use, right? Just so that we can kind of get this in here nicely without having to mess around a little bit too much. And yeah, so this is is kind of weird, where it's like, what are you doing? Why are you doing like all this extra code just so that you can make these functions with this specific type and just be like, hey, don't use this, right? And that might be a little bit weird, but like I said, I do want to be very explicit as to what not to do as well as what to do. So we're going to define float vec2 as struct, and there's our like polyfill for the float vec2, right? And then down here at the very end, we want to define ERR for air. We're going to define that as AAC 2020 poly OGL halt, right? So namespace it based on the function that we're actually inside of. Now, we actually don't have a halt function yet. So we have this include gar, we got this init none. So we're going to say that, you know, halt is typically the first function. And 489 paste. So we got to do 489 paste. And then we're going to just take the stars, so anywhere where there's stars, ooh boy, there's more stars, but anywhere there's these specific stars, we're going to replace it with poly OGL for the namespace, and then also put the namespace here as well, so poly OGL. So if we crash inside the system, we kind of know where that's coming from. Now, 489 is actually out of bounds. We need this to be between 0 and 255, so it's 1146, so we could call it maybe 114 or something. I don't know, like I want some type of 1146. I don't know, just give it some type of, like, we're never really going to use these exit values, but it would be nice to try to like randomly disperse these values rather than always using 666 or 255 or 1, right? Just trying to make it a little bit more dispersed in the very odd chance that we actually care about this exit code. We usually don't care about the exit code, we usually just care about this printf here telling us what went wrong. Anyways, so this poly OGL halt. So originally we had 7 of these, and now we have 8 of them, right? So we're going to take all of these. We're going to go down to the end of this section here. We're going to take these, so we have 7, and now we should have 8. So we should be able to go like this. We should be able to go duplicate, duplicate, and then we should be able to go right over here like this. Ooh, that was not what I expected. Let's just copy this. So let's take this like this. Control X. Let's highlight like this, and then Control V. There we go. So I'm just expecting it to take up exactly the same amount of space. And then we'll just go 04, 05, 6, 7, 8, and 9, right? So we're at 7, we added 2, we're at 9. And then we're going to remove all this nonsense here, right? Because it's it's the undef, we can't have any other weird tokens. And then we're going to do undef like that, right? And we also need a space to get the alignment the same. And then we're going to go up here, and we're going to renumber these. But we have this checksum here. So let's take this checksum and actually put it to use, right? So if the checksum checks out, then you should be able to just go like this and go bam. And yes, yeah, that works. Okay. So the next part that we need to look at is, I don't know, just getting this running. Just getting it to compile correctly. All right, if we really think about it, like, we've made these changes, and we've stubbed in these 2 functions here. Eye resolution, CPU, right, the width and the height. So what we really want to do now is just just make sure that this still compiles, right? So we haven't changed the body of this function, but we've added these 2 new functions. We just want to make sure that our build system can take this stuff and properly convert it into GLSL code. So float32 for a second. So the first thing I'm seeing here is I don't see a float32 anywhere else except for these 2 spots. So we actually have to address that, right? So if we look in here and we go float32, where are you? So we have float32 make. Interesting. So we have float32 make, but then we don't have any float32 type. That's fine. That's because we kind of inlined the use of float32, and then we have like a float vec here. But yeah, so over here, where we have our different type macros, we're going to have to add one, right? So we're going to have to go put this somewhere. So we got the U32, I32, IVEC, whatever. So I feel like maybe putting it at the top would make sense. It doesn't really matter, but putting it somewhere where it just categorically grouping these together in a way that makes sense is a good idea. It's not a requirement, but it's a good idea, I think. So I think that it kind of belongs right here. And then we can just shift this and shift these numbers up here. And then air is now the 16th define for the section, right? So then we can look at this type macros here. And if we follow these, we can end up at the top of the file here, where we have different types depending on if it is GLSL code or if it is C99 code. So now we're just going to, we can fix that while we're here. I did some refactoring and changed the length of some lines. Yeah, so right here we can do the exact same thing, right? So we can just go, we can just duplicate this, and then we're going to call this float32, and we can duplicate this, and we can call this float32, and then when it's C99 code, all we're going to do is say float, right? So float is going to be 32 bits. There's no template type. Like, there's template types for the bit width types, but there's no template type for the float type, as far as I know. I mean, there might be some, I'm sure somebody's done some type of library for this, but I don't know of any standard library that does that. And if anyone knows, that would be helpful, but I don't think so. So then over here, right, so this here is, I don't know, is it still going to be float? So I think that GLSL float type might be exactly the same. So let's make sure that that's the case. So float type GLSL. There might actually not be any difference with GLSL float and C99 float. I think it's the same kind of thing. Oh boy, what the heck is this about? Zoom. The zoom is 500%. Oh, okay, well that is... Whoa, geez, what the heck? Okay, we're experiencing some technical difficulties. And that What the hell? So I can't get out of here. The escape key is not working. We do F12. Yeah, what the hell right now? Like, this is complete crap. What is it? Alt F4? Alt F4? Yeah, there we go. Let's try that again. And now, was that, did I do something wrong, or was that site just like a intentionally malicious site? Did I just go to intentionally malicious site, or are they just why is my zoom, what, F11, huh? So whatever happened to escape being the key you use when you panic because something goes wrong, like, you know, full screen. Zoom, what the hell? Like, are there cookies that remember my zoom Okay, so anyways, basic types. Let's look at scalars. And we have bool, int, float. Yes, it's actually the same name in GLSL and, so if it's GLSL code, it's called float. And if it's C99 code, it's still called float. So that's one of the cases where it's just the same. It's not always that case, but sometimes it is. And even though it's the same, we're still gonna do it like this, right? So even though it's the same, we're still gonna keep it like this in two different sections, because it's kind of like a what we have here is kind of like state management, and we want to keep everything nice and organized. When I was first learning to program, I would be like, oh, well, F32 for float is the same in both, so let's just keep it outside of this kind of block, if-else block, because it's the same for both, so why not? But the thing is that don't just do things to save lines of code. We don't care about how long the code is, we care about if we can understand the code, if that makes sense. So, yeah, so F32 is going to be this float thing here. And there's 16 of them. There's no checksum here because we just don't have room. But we could while we're here, since why not? Why not make a little checksum, right? So we can't make a checksum for everything. But it might be nice to just have like 1, 2, 3, 4, 5, 6, right? And then we can just pick back up here, right? And so now we're at 7. 3, 4, 5, 6, and this is 7. This is 8, this is 9, this is 10, this is 11, this is 12, this is 13. And then right here, we got 14 and 15. Right, and then this last one's 16, right? So, not the best way, but, you know, just to keep things nice and organized and checksum what we can checksum, you know? Okay, so we have that, and now we have a definition for float32. So when we use float32 in a function, we know what that means, right? So that looks pretty good to me. I resolution width, I resolution height, and this is from the CPU uniforms. So I'm satisfied with this. I think I can understand where everything's coming from. And like I said, we haven't done anything to where we've added any new features. We've just made it so that we're adding kind of more framework to add. Before we add more code, we want to get more of a foundation down. So now we're just going to make sure that this compiles, right? So expansion of macro, conversion to non-scalar type. So define float it's in poly-OGL. So let's go look at poly-OGL in the functions. What do we do here? So this thing here, inside this struct really quick. Let's take a look at this struct and see what kind of screw-ups screw-ups we did here. Now, did we forget to... It should be correct. Oh, float vec 2. This is a float vec 2. Oh, we made float vec 2 because float vec 2 is going to be for this. And we just want float vec 2 FV2, right? And then right, so it has two parts to it, right? For this one. So we want to do it right like this, float vec 2, right? And then for... Also, did we do this correctly? So we got 9 here. Do we have 9 on the bottom? Yeah, so we did that correctly. Okay. So we remembered that. But yeah, so this is float vec 2, and this is float 32. So we just, when we kind of cut and pasted this code, we kind of didn't think about what was going on exactly. So let's give that a run and see if we can get this working. And pedantic, so once again, I have this habit where I really like to write my functions like this. But it's being compiled as strict, it's being compiled strictly, so we cannot have commas at the end of a function scope. So let's just save that, and let's give it another run. And once we hit an hour here, I'm gonna either stop the stream or at least go upstairs and check on what I'm cooking. Okay, so this seems to still be working. Awesome. So my build system is still intact. So let's go look at this fragment shader and see what else we can do to make this a little bit better. So right now we have this like RY thing here. What I would like to do is that RY is just this height thing here. So I'd like to take this function, and wherever we're using RY, we're only using RY in one place, right? So I'd like to just kind of say, get the height, right? We want to get the height, and then just invert it, right? So we want to take the height, we want to -1, and then we want to flip it around with the, we want to flip this y coordinate is what we're doing, right? So we get the height when we -1 to get the maximum y coordinate, and then once we have this maximum y coordinate, then we invert it by using the current y coordinate. And then we also want to -0.5 so that we have a discrete pixel coordinates rather than these texel center kind of pixels that Glsl is very fond of. So let's give that a run and see if that new kind of polyfill kind of function works, or if we've made some type of serious mistake. And we're not really going to know until we go to the shader and see if we got a syntax here. Oh, nice. So everything's starting to come together pretty seamlessly, so I'm getting happy here. Okay. So now that we have this, the next thing we want to do is it'd be nice to just do a little texel fetch of... do a texel fetch right here rather than a color gradient, just so that we can see what is currently on that memory, right? And I don't know what we called it, so let's go... Well, actually, we just call it texel. We call it TF for texel fetch, I believe. Now, the thing is that for texel fetch, for TF, we need to... How does texel fetch work? TF... It takes the sampler. So the texel fetch really does need to include the sampler we're using, even though the polyfill isn't coded correctly, because the texel fetch needs to know... The texel fetch is eventually going to sample from different memory, right? Right now, that's not the way it's programmed. Right? We're just ignoring... Like, if we go look at this and look at the texel fetch, this thing actually needs to be a different value depending on what the sampler is, right? So the U32 sampler should actually be a number that is based on what memory we actually want to fetch from. So we need to make sure that we fix this as well. So so we need to put that on like a little to-do list or something. So file, new, to-dos. And let's put this in our documentation, right? So we do not want to overpopulate this main folder here, right? We got a license, we got this we got a license. This thing is auto-generated. We got this README, we got this Decton logo, right? We got more. We already have more than I'm happy to be in here. Like really, all I really want in here is kind of like a SH file and a C11 file. But a README was also a good idea, and then a license was also a good idea, and then a nice little logo was like, why not? So we don't want this at the top level, even though you could argue that, well, a to-do is something that could belong at the top level, but we don't want to do that. We want to keep everything where we don't want to overwhelm somebody when they open up this project for the first time and just have tons of stuff in there. So we're going to go into the documentation folder, and we're just going to say, now we could just say documentation to-do, maybe, or we could also make a folder for this. I'm going to put it to-do here, so to-do dot underscore. And I just want this to-do because I think we could eventually forget about it. But actually, the reason why we're not going to code it right now, so if AAC 2020 crash the reason we're not going to fix this right now is because we're going to have to, once we fix this, we're going to have to actually run some tests to make absolutely sure we don't break anything, and that's why we're not going to fix this right now. But we absolutely need to get to fixing this eventually, because this Glsl fetch it's not going to line up with our CPU side code if we don't implement this U32 sampler variable. Right now it's hard coded to always use this piece of texture memory, right? So this is the CPU side allocation for PAINT5D. So this is what represents the texture memory in OpenGL on the CPU side, and this needs to be this fetch needs to be different depending on what value is provided into here. So we need to fix that. And also, yeah, we need to fix that, and yeah, we'll get to that. But right now, let's just say hashtag error implement U32 SAM on CPU side. Right, so we obviously have to do this, and we can make a note here in case that doesn't make any sense to us in the future. We can make a note that we're on video 116 and the time is 43 minutes and 2 seconds, or 44 minutes and 10 seconds. So for the video, we want to make sure that this Glsl fetch command actually uses this U32 sampler, because right now this Glsl fetch command is hard-coded to always get from the PAINT5D system, and that is going to break down once we want to write unit tests for other subsystems that use different texture memory allocations. So this is fetching from the bitmap on the CPU side that represents the texture allocation called PAINT5D. But sometimes we don't want it to grab from PAINT5D. So if U32 sampler is 1, then we want to grab from here because PAINT5D is subsystem 1. But if it's 2, then we want to grab from something else. And if this U32 sampler is 0, then we want to grab from subsystem 0, which is the Tau depot memory. And so this would still need to be different. So we got to fix that around, but right now we're just going to put a crash on vital to do to make sure that we don't forget this. And what else are we forgetting here? I feel like we're forgetting something, but I can't remember. We're looking at Glsl fetch. We're looking at Glsl fetch to see how it was used. Yes, we're looking at Glsl fetch to see how it was used, and then we realized, oh crap, Glsl fetch is going to break down on us in the future if we don't address this. So we're just gonna say we want to do a Glsl fetch, and we want to say paint. I want to say PAINT5D, or did we say P5D? I think we said P5D for the PAINT5D system. And then we want some type of IV2 chord here. And then we want, and this is 0. So the level of detail is always 0, but that's kind of how we want to do this. And so now the question is, well, we have a case where we're using this somewhere, right? And why is this here like this? Why is this not... Why is this Glsl fetch? Is this CPU side only code? Why is this like this? P5D OGL Glsl fetch. Is this a wrapper? Oh, this is a wrapper for this Glsl fetch. Oh, it is a, Oh, got ya. So this Glsl fetch gives us a packed pixel, whereas, this Glsl fetch here, gives us a UVec4. Okay, I see what's going on here. That's fine, that's fine. I just want to make sure that when we're looking at this code, everything kind of makes sense. So that makes sense to me. So the next thing I want to do, before I even try to use a Glsl fetch in here, I was kind of mucking around, so I'm kind of concerned, and I want to make sure that this still compiles. I still want to make sure my shader compiles before I try to add more code. Make sure I haven't accidentally introduced some type of mistake. Okay, so that still works. So yeah, so right here, let's just do like a Glsl fetch. So we can... now, because of the way we need to write this, we can't do any weird things. Like, Glsl will let us do constructors in, like, in a weird kind of way where, like, if you want to do, like, a constructor to create a float vec 4, you could give it a float vec 2 float vec 2s, or you could get a float vec 3 plus a float, or you could give it 4 floats, right? You could combine in all sorts of ways, but because we're writing this in a way where it has to also compile as valid C99 code, we'll have to do things in a little bit more steps than you may be comfortable with. So we're going to do a Glsl fetch, and we're going to do PAINT5D. We're going to look for the PAINT5D system, and then we're going to say this right here. I believe Glsl fetch, this Glsl fetch should use a integer coordinate. Actually, I'm not sure, so let's look at that for a second. So Glsl fetch, the poly OGL Glsl fetch, how does that work? How's the signature, right? So the signature itself should, let's look at that signature right now for the Glsl fetch. Does that Glsl fetch UVec4 and then IVec2? It takes the IVec2. Okay, so it takes the IVec2. That's fine. It'd actually be nicer if it didn't, but that's the way it works. So okay, fine. So PAINT5D, and then we want to do IV2 make. Right, I want to do IVec2 make. Right, so we want to create an IVec2, and these are int32s, right? So we want to take This kind of does suck a little bit, I have to say. But yeah, we want to take these two values, right? So and then the level of detail is 0. Alright, so text will fetch from PAINT5D. And also, let's do this. Text will fetch from PAINT5D. I don't know if I like this. Here, let's do... If we have room, then why not? See, I'm just getting kind of... taking too much time to figure out how I want to format this. How about just a one-liner? How about that? How about not formatted at all, right? How about just... right, because we could do that, that's fine. And then we could just do, like, this text will fetch is going to be a UVec4, right? UVec4. And it's, it's a P5D pixel, right? It's a PAINT5D pixel, right? Technically, how about UVec4, and specifically it's from PAINT5D, right? So it's a UVec4 sample of PAINT5D, and it equals a textile fetch, right? So like that. And then if we do that, we just want to use it in here, but let's, I am still kind of paranoid where I think that if I'm not careful, this is just going to blow up in my face. So let's make sure that we have a UVec4 here. So we have a UVec4, that's fine. And we just want to make sure that runs, right? So let's make sure that still works. Implicit declaration of IV2 make. So IV2 make. So we have IVEC4 make and whatever, but it looks like maybe we don't have IV2 make. So IVEC2 make, right? So we do not have this, so we need to make a polyfill for that. So let's go copy that and look at some of our functions. And we should have like all these different kind of like make float vec4, make I32, make F32. So we got I thought we had another maker function for so we want something to make a int vec2, right? So I guess the place where that would make sense is kind of like between here maybe. So glsl polyfill make int vec2, right? So this is what we want to do. And we just want to say, you know, int vec2 AAC 2020 poly OGL, and then this function here, right? And then we're going to say it's going to take two float int 32. Sorry, it's going to take when we make it int vec2. Right now we're just using integers, right? We're just using normal integers to do this. So now later we might have more complicated use cases, but right now that's how it works, so let's kind of keep it like that. So float int 32 int x and int 32 int y, right? So we're just going to take the integer x and y and just cram them together and be done with it. So this is what we eventually need. And for that, we need something like this. So let's steal this. Let's steal this code, right? Because this is the basic structure that we need. But instead of float vec4 like this, it is going to be int vec2, like that, right? And so everywhere we see this, we can just go iv2, this can be iv2, iv2, this can be iv2, iv2, and then we only have two parameters, right? So iv2.x and y. So just go like this, bam, remove those other ones, and then instead of float x and float y, we want int x and int y, and we see we made a case mistake right up here, so let's fix that. So x and y, and ivec2, right? Very original naming. We're just going to name, the type is ivec2, the variable is also ivec2, just because we don't really care, right? We don't really have any other context for what it needs to be except for its type. So we'll use that to reduce the cognitive mental load of what's going on. So now that we have this nice little function here, the next thing we want to do is we want to go into this fragment shader code, and we want to add this somewhere. So let's go look at the float vec4 make. So we got float vec4 make, we got int32 make, and let's just put it down here. So let's do undef float int vec2 make, right? So that's what we want to do. We want to make an integer vector. And also, I need to check on my food soon. So int vec2 make, and so let's find this function where it's actually being kind of declared. So up here, it's being declared. So we're just going to add some new entries beneath this, right? So we're thinking define int vec2 make, and that's going to be this function here. So oh, wrong. No. It's not going to be this function here, because this is the OpenGL code. So for int vec2 make here, we're just going to say, ivec4, right? So integer vec where the integer vec where it's a signed integer, right? So int vec. So this is the part where we have to be very careful, right? Because we don't get this conversion between the OpenGL context and the OpenCL context, like our whole pipeline is not going to work. So you got to be very careful about these transformations. So ivec2 is going to be not an ivec2, but it's going to be a ivec2, right? So we're going to use the ivec2 type as a constructor because we can do that when it's OpenGL code. So that's how we're going to do it here. But when it's a C99 code, we can't do that. So ivec2 make is going to be this ivec2 make function here otherwise. Now, I see we're kind of lacking some checksums here, probably because, you know, this takes up a lot of room. But we could actually, what we could do here is we could just take the... All right, we already have kind of this sectioned off kind of thing going on. Why not just use that to create checksums, right? Instead of just calling it hashtag whatever the heck, maybe it would be more useful to have a checksum here, right? So we could just say right here 1, 2, 3, 4, 5, 6, 7, 8, right? There's 8 things here. So we could just go 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't know why I said 8, because there's actually 10 things here. Right here, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we got to think about what's going on here, because it looks to me like we added a little checksum and the numbers don't match up. So, first of all, that's because this is not correct, right? We were starting here. So, 1, 2, 3, 4, 5, 6, 7, and then this is 8. Okay, so that's 8. So we got 8 things here, and we got 8 things there. That is correct. Okay, cool. So ivec2 make is going to be this, if it's OpenGL code, just ivec2. Otherwise, we're going to use this OpenGL polyfill that we created for ivec2 make. And now we just want to see where we're using that. So we're only using it in one place, we thought, yes. We're only using it in this one place. And so our hopes is that we've done this in a way where it's just going to work out of the box. Now let's look for P5D and match the case really quick. And see, P5D is PAINT5D or 0. And actually, it should not be 0. It needs to be 1. It needs to be 1 because it's system number 1, right? Now, what other mistakes are we making here? So this is good here, where we have... So the IVEC2 make... Are we undeffing it? Oh, we are undeffing it, so that's good. Okay, so the other thing I want to look at right now is P5D... Or actually, no, let's look at this for a second. So... let me look at this again. So we got 8 things. Or do we have 8 things that are being undefined? Right, because now we have this nice little checksum. Is this also 8 things? 1, 2, 3, 4, 5, 6, 7, and 8. So it's also 8 things, so I'm satisfied there. I do need to check my food, so I'm gonna... Before I burn it. So let me just... I think I am kind of... I just want to go up there, check it really quick. So I'm just going to put a little timer here. And it should be only like 5 minutes at most, so... we're going to give it a little timer. And maybe I'll heat up my tea, add another tea bag. But 5 minutes, I'll be right back. This is the break screen. I'll be right back. Okay, so 400 degrees for an hour with a little bit of water and some freezer burn chicken looks like a little bit too much time, but not enough to where everything got burnt to hell. Like where my rice got fully cooked, but then got a little bit crispy on the top. So not bad. I mean, could have been worse, but it's at least eatable. So, I'm going to take some time to eat my food. and maybe check out on some other streamers or whatnot, because I'm in a good point here for, yeah, now I do want to make note of something to do after the break timer goes down, so, also, it is now another day. It's now a new day, so actually we gotta go back down to 0 here. And Friday, yeah, it's just the total today needs to be changed, okay. Okay, so really quick before I go though, because I have this food and I don't want to like completely be eating it the whole time while I'm talking. Before I go, we should at least make sure this compiles, right? So let's try to get this working, and then also I want to put in this P5D. I also want to create a thing called tau. So tau and P5D, and put them in the order that they belong. So actually, let's do that first. So let's go right here. We're gonna undef tau, and tau is just the first piece of texture memory that we may want to use. And we can expand this to have like 17 defines now, right? So 17 instead of 16. And then we want to look wherever P5D is in our defines, we just want to put tau above it. So right here, we're just going to go up here, we're going to define tau as tau depot, right? So tau depot, I believe is what we called it. We can make sure of that, so it should be like at the, yeah, tau depot and PAINT5D, right? So these are texture memory blocks for the different subsystems. And we just want to make sure that that they're mapped correctly in here. Because right now, originally in the code, before I started this stream, PAINT5D was resolving to 0, but really it should resolve to 1 because it's texture memory slot 1 and subsystem 1. And then we can define tau over here as 0. So tau actually does get slot 0. Right? And we can put that in here. And then we already undefined tau, I believe. I think we already undefined this stuff. So the checksum here is going to be a little bit harder, but we can kind of 13... so we got 13, 14, 15, 16. So 16, and then this is 17, which matches with that. So that's good there. And now let's make sure that tau is undefined. Tau is undefined. I think we already did that. Yep, so, okay, cool. That's good. So let's give this a run. And we're going to stop the stream once we get something actually compiling here, right? So that I can take a little break and check up on other people and all that good stuff. So, unused variable. And indeed it is. Because I didn't want to commit. I did not want to commit to this right away. Like, I want to just add this one line and test it. And this would work as Glsl code, but here in my C99 code, it's like a very strict setting, so it's saying this is unused. And that is true. So we know this is a UVec4, right? So we need to do something like this. We need to do like, so this is our UVec4 .x, and we're gonna take it, turn it into float 32. Y XYZ. We could also do the same thing for the alpha, if you really wanted to, though that might make it a little bit confusing because we're trying to view like the pixel, and if it has transparency on it. It might make it harder to see what we're looking at. So right now, we might just want to do this and call it good. So this is just, hey, I want to know what's on that texture memory, right? I want to be able to visually confirm what's in that texture memory. And we've already done this previously, like many months ago. Or maybe not maybe months ago, but maybe a month ago we did this. But now the goal is that we have this more robust framework for our shader code. And we want to at least get to this step before we go any further. So right now, oh god, no, that's right. Oh, crap. So we kept on thinking that our code was working. But guess what? It might not work because, like, maybe we're careful enough, but we're not going to know until we go into this mod folder and delete this. So, oh great. So maybe, so the idea is write a little bit of code, test the code, write a little bit of code, test the code, so that we don't compound errors. Because if this shader code does not work, we may have introduced more than one error, and this could be actually quite hard to figure out. So let's hope this works. Ooh, nice, out of the box. Excellent, excellent. So all this shader is just kind of like showing me what's on that texture memory, so that I can verify that, yes, I can indeed do a texture fetch, and indeed that is what is on the texture memory. So excellent, excellent, excellent. So the next thing we want to do is, I think, well, let's look at that to-do list and see if we can't just kind of get this done and over with. So why not just fix this while we're here? So this Glsl fetch, right? So we want something that is like, instead of CPU picks, we want, we want a pointer to, instead of this, we actually want like a variable, really. So we want something like this. We want, longer, hard-coded. So we want to pick your memory block. That's what we want to do here. Right here. And for picking this memory block, we just want to, right how we define CPU picks, that is going to change. We're going to, we want to make something like UO8 pointer CPU picks equals a UO8 pointer cast of 0, right? So it's null. And then what we want to do is we want to say that if U32 or 0 equals U32 sampler, then CPU picks equals, and then this big guy right here. And that's actually kind of long, so what we're going to do is something like this. PAINT5D CPU picks, right? So something, let's try to keep it kind of short to where we can, or we could do P5D. Yeah, because eventually we're going to pass in P5D as the number. P5D or tau or whatever. So, and 0 is not correct, right? It needs to be 1. So, 0 else this. Actually, we could do a switch here. Let's do a switch. Switch U32 sampler And we got case 0. We're going to do something. Otherwise, we break. And then case 1, we're going to do something. Otherwise, we also break. And default, if we get to the default, then we're throwing an error. So, error, bad texture, memory, integer. Right, so, bad enumeration. And the reason why I guess I didn't want to do this is because this is just very... this looks a little bit nicer, but if we do this, though, then we can... we have enough room where we can avoid some of that indirection, right? I think we can say just CPU pix equals this, which might be nice. So this is tau depot. And then we can take this one, and we can say CPU pix equals PAINT5D here, right? And we can, now that we have it like this, what we could also do is we could just we could make a clear association between those shorthands, right? So when we have like the case tau, right, and the case P5D, we can create an association between what those mean in the shader code now, right? So we can go up here and we can go define tau as 0, right? And then we can define P5D as 1. So now the thing is that we're hard coding this in here. And so some of the system design is hard coded to where if we change our mind on this, we're gonna be in a world of hurt. So so the whole idea is that system 0 leads to texture slot 0, right? And I can't seem to spell system here. So yeah, system 0 leads to texture slot 0, and system 1 leads to texture slot 1, right? A little one-to-one mapping here to make things very simple in the project. And then, so these are kind of the shorthand names for these systems, right? So tau equals tau depot, and then P5D equals PAINT5D, right? So there are shorthands for what we're doing here, right? And then we can create like a little checksum here, so we only have 2 things, so 1 and 2, like that. Okay, so CPU pix starts out as a void pointer, and if we do not assign it, right, because none of these cases get invoked. Alright, so here's this memory, CPU pixels. So now this CPU pixels here is just going to be, we could just call this CPU pix, right? So we could keep the structure here, but that is kind of stupidish, you could say, but whatever. And so now that we have that, we have kind of changed how this stuff works, and we may find ourselves in a world of hurt if our tests are using 0 for the Glsl fetches, right? So before we close out this stream, we need to run the code, make sure it compiles. Unknown type name. So, yeah, first thing we have to do is fix a few things, right? So, in this polyfill for Texel fetch, we need this UO8 type. Now, what about this int32 type? Where's that coming from? Is it just like at the top of the section? Like, where is that? So all the polyfills are getting like, we're declaring all of these different types like up front. That's fine. So we can define a UO8 type, right? So UO8, so it's a byte array. UO8 is just a byte array type. And we need that byte array type because byte arrays are the format in which OpenGL uses to store pixels. So 4 bytes in that array are equivalent to 1 pixel. So yeah, so we have 10 things here. And now we can just kind of look for the bottom of this. And we know that at the very top, we want this to be our UO8, right? So we'll kind of shift over this checksum here. Now we got 10 things, and this right here at the top is our UO8 type, right? So UO8, now it can be used in this code. So uint8 type, and that's right here. Now the reason why we didn't need it before is because before we just kind of like hard-coded a reference to what we were using, which was a uint8 type, but now we have to do this, whatever. You get the idea. So let's run this and see if we can get that compiled. Let's look at the mod folder. So the shader number 1 is missing, and when we compile this, it's going to get regenerated. So it's going to get regenerated from the source, and we can see if that's correct. So CPU picks redefined. So what do we do here? How do we screw this up? CPU picks, define CPU picks as CPU picks. Oh, hold on. So first of all, this is a problem. So we undefined it, but we used lowercase, right? So we actually want uppercase. So that's a mistake, which would have costed us. So how about this? Let's kind of line that up kind of nice right there. I don't know if that's a good idea. Yeah, we should give it a little bit of space, I think. Let's get a little designy here. And yeah, that's all we need to do. So we're going to get this running eventually. We're going to get it compiling, and then we want to run our unit test really quick. Make sure, have a sanity check, right? We've kind of mucked around a lot. Okay, so that looks good. So we've mucked around a lot, and we really want to open up our unit test manager. So it's called test killer, or kill test. And it's called kill test. And if we look at the data, we have a way to turn on all of the functions. So all tests off or all tests on. So we have a big override here for this thing here. And if we do 1, everything gets turned on, right? So basically, if it's, if we do 1, everything is going to get turned on. And we can do like a thorough test of everything and hope that nothing breaks, right? So cross our fingers, hope that we have not broken anything. But if we have broken something, then, you know, well, it's a good thing we have tests, right? So tests are there to verify the correctness of the code, but they're also there to help us find mistakes. So Glsl fetch definitely broken 2021. So let's go look at that. Let's go find that. So it's nice that we know we messed with Glsl fetch, and that was the thing we were concerned about. And guess what? The error message actually informed us of exactly what was going wrong. So Glsl fetch definitely broken. And, well, let's look at this. So Glsl fetch here. So the texture sampler here that we're using is it's just passing in 0. But we want to pass in, for these tests, we want to pass in 1 for PAINT5D, right? So what we're going to do here is, for this Glsl fetch, we're going to say define P5D. How about P5D texture, right? PAINT5D texture memory slot. Yeah, it's PAINT5D, and then we can undefine this down here, right? So we'll just undef it right here. PAINT5D texture, whatever the heck. And while we're here, we might as well kind of like, we might as well kind of make a little checksum area. Or say, hey, I got these 3 things, right? So we're here, let's just make it a little bit nicer, right? So this PAINT5D texture here, in the Glsl fetch, right? So this is where it's saying the Glsl fetch is definitely broken. And we see that this is no longer correct, right? We want to use P5D texture here, right? And I don't know how we want to do this. I guess we could do it like this. Sure, why not? Always 0 in all code. Texture sampler. Texture, system, texture, so this is the system texture memory to sample. So we really want to look for anywhere we're using this and make absolutely sure. So we need to look for anywhere we're using this and make sure that we're using it correctly. So these versions here, these old shader versions, yeah, they're not going to work. We should just delete them, I think. I think we should just delete these. So this old shader version code, but like stuff like this unit test code here, we fix that. What about this? Do we fix this? So now this is no longer Glsl only. So that's this P5D, that's good. And P5D, well, is P5D the correct number here? So if we look at P5D right here, is it set to a 1? And this is the fragment shader. We already know we've set that to 1, so that's correct. So Glsl fetch U32, this is in the stringified code, that's fine. And this is the fragment shader code. And once again, Glsl only. Okay, so let's close this. And in here, oh, this is the dispatch. Okay, yeah, so we can close this. So yeah, it looks like we only had this one little problem. However, in the fragment shader code, we really should, where we say Glsl only, that's no longer true. This is this is C99, C11, and... Right, so originally this was the case, but now that's no longer the case. This variable actually needs to be used in both cases to sample from the correct memory. So this U32 sampler, it's a U32 sampler type in the Glsl code, but in the C99 code, it's an integer that tells us what texture sampler we're using. So it needs to be used in both cases. So let's give this a run again, and actually go into the mod folder here, and let's delete this shader again. So we're going to delete this, and we're going to give it a run, and it's going to run all of our unit tests, because we have this override that says run all unit tests that is currently active. And we're just gonna hope, cross our fingers, that everything works now because we made that one fix. Alright. So far, it looks pretty good. Now, this test does take a long time, and that is why I made a, a whole system to turn off unit tests, because we've gotten to the point where we can't just run unit tests every time we start with a project because of the amount of time that is being consumed in these tests. Now, I do like that the tests are very thorough. Also, one of our other tests, we have one more test that's lazily invoked right now. So once we go over to the first subsystem, you're going to see the project halt, or not halt, but freeze on us. So we're going to go right over to the next system, system number 1. The screen's going to freeze for a while because it's lazily executing some more test code. Now, this is something where maybe I need to get rid of this lazy invocation kind of stuff now that I've kind of refactored how the test code runs. But for now, I think this is fine. And yeah, so all of our tests passed, so that's great. So we made a few changes. Our test code had detected that as we made changes, we broke some stuff. The breaks that we made were pretty easy to fix. We fixed them. We ran the code. And now if we go into our mod folder, this shader we deleted has been reinstantiated. And if we look in it, this is all of our C99 code that is written in a way that it can run as Glsl code, and it's just in there in the shader. So we got this nice, beautiful, crazy shader code in here, ready to go. So now let's think about what's the next step here. What is the next step? Well, the next step is to, well, start writing more of this shader code here, right? We want to write more of this shader code here, and just get some meaningful renderings on screen. But before we do that, we need to make sure that we can. The next step here is make sure P key for pattern uploads to GPU, and we can see it do this before making more elaborate shader code. So, before we get to making more elaborate shader code, we need to make sure that the P key for injecting a pattern into the texture memory, we want to make sure that that P key actually works for the GPU side texture. We know it works for the CPU side texture, but we don't know if it works for the GPU side texture. So we need to make sure that we can do that. So 32, or let's just call it 33, because it's about to be 33. So to reiterate for the camera, we are not going to write any more shader code until we can make sure that when we press the P key for a pattern, that pattern also gets uploaded to the GPU. We know the pattern gets uploaded to the CPU side texture, but we want to make sure that that pattern also gets to the GPU equivalent. We want to be able to observe that pattern in this shader code before we continue any further. Because if we cannot observe that pattern in the shader code, then anything that we build on top of that is just not going to work. So what I mean by that is, let's give this another run really quick, but let's turn off these tests. So let's turn off the override here. Let's run this really quick, and we can delete this, sure, why not? Give it another test here. So if we run this, did I make sure P key pattern uploads? What's wrong with my multi-line comment here? What the heck is this? Expected blah 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 before. Okay, so it looks like it's looks like my multi-line comment is like right up against. Right, this is why you have this implied boundary, right? Because that way, so if we're here and we go 1, 2, 3, 4, Right, if we back off just a little bit, then we get rid of that problem, I believe. But that's why we have that implied boundary, is so that when we're trying to stringify this stuff, it doesn't break on us. So that broke on us because of that. So our build system isn't completely perfect. Make sure P key for uploads. Okay, hold on. I know what I'm doing wrong. Because this code is stringified, we cannot be doing quote marks like that in any commentary. No commentary is allowed to have... I thought it was a different thing. I thought it was the comments. The comments also need to be pressed in this much away from the border. But yeah, we can't have quote marks in our code because we pre-process it to like put it in a big string, and so we need to not do that for this build system to work properly. So, right, I thought it was just a little trivial change it was just a comment, right? So that goes to say, like, right, there's no such thing as a trivial refactor or a trivial change, right? We edited, like, a few lines of code, and the only thing we did was change comments, right? And we still broke the system. So don't think that, you know, with any kind of project, chances are you don't have some omniscient understanding of the entire project, and any kind of trivial change can actually break things, even things like editing comments. So anyways, right here is what I'm talking about. So this is what is actually currently on the texture memory, and it's just a little checkerboard pattern, right? Just to verify that we can actually see what's on that texture. So we need to try to upload something else. And actually, we could try right now. We could try the P key and see if that actually gets uploaded. And I press the P key, and that does not actually get uploaded. So the P key has changed the CPU side texture, but it hasn't changed the GPU side texture. So we have to change, we have to do a texture upload for this somehow. So let's go do that. Or, not yet. I want to do that later. I just wanted to get to a good checkpoint. So, So what we did here, we didn't really so much change the shader that much. We really just changed the framework around it, right? We changed some of the polyfill functions, and we fixed some things and whatnot. And this project is actually compiling without breaking, so we can push this up to kanji coder as well. And then we're gonna take a break. We'll come back later. This is not my day where I feel super motivated, so we're just gonna do the videos a little bit shorter. Unless I have somebody who's actually watching and wants me to keep going. But otherwise, I'm gonna come back at who knows when and do some more of this later. So I will see you around, and we'll do more of this kind of crazy code later. So, later.